I'd like to show you an early build of Orbital's AI assistant. We call her Lunar. Lunar helps engineers ship integrations faster than ever, connecting real-time data feeds, external APIs, and microservices. Lunar's built on Orbital, so you've got an enterprise-grade integration engine running under the hood. You can build rich, complex orchestrations in seconds through a simple chat interface, and then deploy them instantly with a git push command. In this demo, we'll walk through a Kafka use case. Picture a stock warehouse getting live delivery feeds as shipments arrive. Each supplier is sending updates in a different format, so we'll need to normalize and merge them, enriching them against our internal products API, and then we'll check against our orders API for any delivery issues. Let's dive in. So first, I'm going to provide an example of one of the stock delivery messages that we're getting on Kafka, as well as the connection details of the Kafka broker itself. And I'll ask Lunar to set everything up for me. I can see Lunar's examined the message and generated a schema, and all the code it needs to expose the Kafka topic, including configuring the connection itself. Next, I'll ask Lunar to add the other Kafka message, which contains stock delivery events from our second supplier, FastShip. Lunar generates a schema detecting the fields and the data they contain, including data that was present in our first message, but with a different format, and data that's new. And this is where Lunar and Orbital really stand apart from other platforms. Lunar doesn't just read field names. It understands what the data actually means and adds tags to the schema, categorizing each field. We call this semantic typing. For example, two systems might both have a field called name. In one system, it's a product name, and in another, it's a customer name. Most tools can't tell the difference, but Orbital does. It also understands how different IDs connect systems together, so when you build a custom feed, Orbital can automatically follow those links, even across multiple systems, to fetch exactly the data you need. Next, I'm going to ask Lunar to generate a query that joins both Kafka feeds together, normalizing and enriching them with data that's not actually on the Kafka messages, like some basic product information. Lunar generates the query, and when I hit run, we can see Orbital connect to the Kafka topics and start streaming in live data. If we look at the query plan for this integration, we can see what's actually going on. Orbital is connecting to two different Kafka topics, transforming the data to normalize it, and then calling REST APIs to fetch things like product name. Because the data from each of the suppliers is different, Orbital has generated a different integration path for each of them, making additional API calls to resolve mismatched IDs. We didn't have to tell Orbital how to build these integrations. It can work it out entirely from the semantic typing that Lunar added earlier. Now, let's ask Lunar to work out problems with the stock quantities, finding gaps where the quantity delivered is different from what was ordered. Lunar generates the correct query, including logic to display a message based on the difference. When we run this query, Orbital adds new API calls to fetch the required data. Looking at the integration plan, you can see that it's now much more complex, orchestrating together our original 2 Kafka feeds with now 4 different API calls. Finally, let's have Lunar publish this feed over an HTTP API. Since it's live data, we'll configure it as a server-sent event stream. Lunar updates the query, adds an HTTP endpoint, and we save it to the project. From here, publishing to production is as simple as a git commit and push. To test it, I'll copy the endpoint as a curl command and run it in the terminal. There's our live feed, ready to be consumed by any application. And that's the power of Lunar and Orbital, turning complex integrations into something you can build and ship in minutes.